So in this video, we're going to look at Laplace transform. This is an introduction, basically. So you can see the definition of a Laplace transform is f of s is equal to the Laplace transform of ft. The basic idea of the Laplace transform is that you go from the t domain, which is a time domain, usually, into the s domain. So it has major applications in engineering, especially control systems. So basically, the way it works is that you have essentially got this integral and basically any function f of t. So for instance, if you had the function, for the sake of argument, just a second. So suppose you had the function f of t equals 1, then the integral, so the Laplace transform of 1 would then simply be the integral from 0 to infinity e to the minus st, and ft would be 1 dt. That's a very easy integral to calculate, and that just turns out to be, of course, it's an improper integral, so we'll let's say b go to infinity, okay, and then we'll have here essentially e to the negative 1 over s e to the minus s b. Basically it's going to be just plus 1 over s. Okay, so now as we let b go to infinity, this is going to be equal to, that's going to go to 0, so it's just equal to 1 over s. So we've worked out the Laplace transform of 1, and the Laplace transform of 1 is 1 over s. In a similar way, we can continue to calculate, for instance, if f of t is equal to e to the at, okay, and so this means that we're looking for the Laplace transform of e to the at, which is equal to the integral from 0 to infinity e to the minus st e to the at dt. And of course that will work out to be more like, we can combine the this will be just a minus s, okay, into t, all right, and dt, and of course so that's basically going to be equal to, again, it's an improper integral, so limit b goes to infinity, okay, and the so limit b goes to infinity, and we're going to have over here, first of all, 1 over a minus s e to the a minus s into b, okay, and then minus 1 over a minus s, okay, and basically 0 there. So now if we let so that's then going to be if we let b go to infinity, of course this will all go to 0, and that'll leave us with just 1 over s minus a. So that means that the Laplace transform of e to the at is 1 over s minus a. Now we cannot continue to keep doing these transformations. Luckily, a lot of work on these transforms has been done, and there are transform tables. So let me show you a transform table. Sorry, before I go any further, please notice that this is a minus s, and this is only going to be negative as long as s is greater than a. So this condition, goes along with it. So this together is basically this Laplace transform. It's just what we calculated. Anyway, let me try to show you the table now. So here's a table. This is a table of Laplace transforms. You can see this Laplace transform is 0 is 0. Laplace transform 1 is 1 over s. We just calculated that. So Laplace transform any constant is k over s. Laplace transform t is 1 over s squared. Tn is n factorial over s, and so on and so forth. There's the e to the at we calculated, so 1 over s minus a, and it goes on, and basically all the way down here. Now, of course, those of you who are in engineering courses would be very much interested in, for instance, this the shifting theorems. Okay, these are quite important in most digital type applications, and especially sawtooth curves and step functions and so on and so forth. So you might be interested in this particular one. In this video and the series of videos we have, we'll not be going into those details. So I might do some videos later on that topic, but for now this is just some basic ideas of how Laplace transforms work, and this is a basic Laplace transform table. So that's basically all we want to say here. We'll stop here and continue in the next video and look at how we solve differential equations using Laplace transforms. So we'll stop here. Thank you so much.